your homework here, and I'm realizing I think the definition is where you're getting stuck on. So an element is a single, I guess we'll call it right now like an item on the periodic table. So like there's carbon, nitrogen, oxygen, argon, helium, hydrogen. If it's a single one of those, like if that's the only thing listed, then that's an element. Because that's the periodic table of elements. Now you can have, for example, C4, but it's all made up of carbon, so it's considered like an element. A compound is whenever you combined two or more elements. So like carbon monoxide is carbon and oxygen combined together, so that's a compound. Or water is H2O, so it's made up of hydrogen and oxygen, so it's two different elements, so those are compounds. A mixture is whenever you combine either two elements or two compounds, or an element and a compound, but it's a combination of two different things, so not bonded together. So it'd be like water plus salt. That's a mixture. Or an air, for example. Air is made up of oxygen, nitrogen, argon, helium. Air is made up of a lot of things, so that is a mixture. Or sugar and water, that is a mixture. So if we look down here, let's look at an elemental view of this. Okay, so look at the element. Do you see, look at the colors? That's what they're trying to look at. So do you see how an element is made up all the same colors? Okay, so that's an element. A compound is made of like two different ones. So let's say the red was oxygen and the white was hydrogen. So it's made up of all of the elements, or I mean all the compounds are the same, okay? But you see all of them have exactly two white, two red, two white, two red. So all of these are compounds. Notice all of these are two reds. But the mixture here has a combination of them. So some of them have two whites and two red, and some of them are just two reds, and then two whites, two reds. So you see all the items, if you want to call them, are different. Or there's a mixture of items. Okay, versus here, compounds and elements will have the same exact items throughout, okay? But elements will have the same color, but the compounds will not. I think, let me see if I can look at the one behind it. Yeah, you see here's another elemental one, like all white, but they're all the same. And then the other compound one, well, I guess, let's see. Well, they look exactly the same. Okay, but here, again, they're all the same. All have the same number of whites and the same number of reds. And if we look at the mixture on the other example here, you see you have a mixture of two white ones bonded together versus two reds. Now if we look at another example, I did here. And I'm just going to pull the correct answer and explain why it's correct. Okay, so an element, if you go on the periodic table and if it's listed on there, then it's an element. Like argon is on the periodic table. Copper is on the periodic table. But for example, nitrogen monoxide is not on the periodic table. Or sodium chloride is not on the periodic table. Or air, not on the periodic table. And let me just pull up here. Let me see if I can just... that's not on there. Let me just pull up a periodic table really quick to show you. Periodic table. Okay, so it doesn't want to pull up right now. But if you search periodic table, if it's listed on there, then it's an element. Oh, here we go, finally, sort of. Okay, we'll come back to that. Okay, let me look at this image again. Okay, compound. Notice this is made up of nitrogen and oxygen. So that's a compound. This one's made up of sodium and chlorine, so it's a compound. Okay, so a compound is whenever you start combining elements. So if I combined argon with copper, that would then be a compound. But if they're separate, then it's an element. So for example here, nitrogen and oxygen combined there is a compound. But if I put nitrogen over here and then oxygen over here, but they're not bonded, then those are elements. And then air is a mixture of nitrogen, oxygen, argon, helium. It's a mixture of a lot of things, and so that's a lot of different compounds if you want. So that is a mixture. Let me pull up, see if it pulled the periodic table over here. Yeah, here we go. Here. So here, look. Here's like boron, carbon, nitrogen, phosphorus, sulfur, chlorine. You see all of these listed individually. These are all the elements. This is see right here, periodic table of elements. So here's every single element listed. Okay. Now when you start combining them, then they are compounds. So if I combine nitrogen and oxygen together, then it's a compound. Now when I start combining different compounds, I'm putting them in the same beaker, then that is a mixture. So I hope that makes sense there of what's going on. And then, yeah, so let me know if that helps to clarify anything.